Well, good afternoon, everyone, and welcome to this session about continuous delivery. So, first of all, let me introduce us. We'll introduce ourselves, and then we'll talk a little bit about why we're here and what we want to talk with you about, and then I think we'll go into the meat of the presentation.
Yep. Okay, so my name is Paul Robinson. I work for Red Hat. So I work on the Red Hat Developer Program, where I'm on the leadership team. And my focus is on the developer portal, which is what we're going to talk to you about today. Pete, do you want to introduce yourself?
Yeah, so I work on developer experience related things at Red Hat. And one of the things I've become really excited about and interested in is continuous delivery over the last year. I think for me it's partly about the technology, but it's also about the impact it can have on the people who are using it. It's a much easier way to work. It's a more fun way to work. I think it's a more satisfying way to work. So I think that's what interests me about it. So as Paul mentioned, one of the things we've been working on over the last couple of years is developer portals for Red Hat. So, you know, what is Red Hat Developers? Well, Red Hat Developers is, you know, the way we have recently been looking at ways to make our products and our programs more powerful and easier to use for developers. So, you know, this includes not only new features and products like continuous delivery and deployments and improvements to the product, but also includes things that help developers learn. And that's what really we've been focusing on over the last year. And what we're going to do today is tell you the story of how we went from a more traditional model of delivering things in a sort of dev stage prod typical approach to using continuous delivery, why we did that, some of the pain points we had along the way, some of the lessons we learned. So I think unusually for me, this is not a talk that involves lots of demonstrations or something like that. So it's quite a lot of, you know, it's very much a story. It's very much about why we did it and what we did. So first of all, we just want to tell you a little bit about the architecture that we're using and the environment we're using so that you can understand, you know, as we talk through some of the things that we learned, you know, what we're talking about in a little more detail. So we have a website. It's got about 1,000 pages on it. The source code for the website lives up on GitHub. And we pull in loads of data. So we pull in data from social media. We pull in data from video sites like Vimeo and YouTube. We pull in data about books. You know, there's been lots of book signings going on this week. So we pull in lots of data about books that have been written about JBoss technologies. Pull in data from the customer portal. Pull in sample applications from GitHub, et cetera, et cetera. We push this through a build pipeline, which then spits out a website that's composed of HTML, JavaScript, and CSS. And then on the right-hand side of this diagram, you can see an overview of what we do in production. So we have some HTML that's served up using Akamai. We have some static resources like JavaScript and CSS that are served up, again, using Akamai. And then we use it's interesting, I was talking about this with a colleague last night about, you know, we were talking about microservices and what a microservice is about. And I said, well, I don't necessarily think I believe in microservices, but I definitely believe in non-monolithic services. And so I decided I'm going to call this non-monolithic services. We don't have thousands of services, but we have about 4 or 5 that do all of our dynamic work. The reason this architecture works really well for us is because it's optimized for performance, because we can deliver the resources we need to the web browser very, very fast over the CDN, but then we can also talk back and get dynamic information into the site, such as searching or SSO or access to binaries, restrictions, etc., using our dynamic services. So briefly on our build architecture, our build system, what we do is we have a set of data that we pull from places like I said, like Vimeo, YouTube, GitHub. We build that, and we build pages from those and push them through our continuous deployment pipeline in Jenkins. We also have some other data that gets pulled in and gets pushed into our search engine. And so these two things form two things. So I'll explain this very badly. So we pull all this information in, which is on the right-hand side of the slide, push it through our continuous deployment pipeline, and generate pages from that. At the same time, we also push that information out to our search engine so that people can view and easily find the information we have. We also push a little bit of extra information which you can see on the right-hand side, and that gets pushed directly into the search engine. The difference being the stuff on the left we need to generate pages for the website. The stuff on the right we're going to link out to. Well, that's our indexing architecture. We then have our runtime architecture. Well, sorry, that's our build architecture. We then have our runtime architecture. I've talked about some of this before, but pretty simply we have 2 Akamai-based servers, which talk to our backend servers running Apache to serve up our static content and our resources. We also have the web browser then talks to a number of our dynamic services, such as our search engine, our SSO solution from Keycloak, and also some custom services that we've developed around providing access to binary downloads and things like that. So if you go to jboss.org or developers.redhat.com today, this is the architecture we're using for that system. But I'm not really here to talk, or we're not really here to talk about our website. When we love talking about our website, we love talking about the architecture, we love talking about why we've done it this way. But that's not what I want to talk to you about today. What we want to talk to you today about is the journey that we took from a setup that's a lot more like this, where we had some developers working on machines. They pushed to a staging environment, and we'd sometimes do some releases. So first of all, we're going to talk a little bit about why this infrastructure, which is really common to many people in this room, right? This is the classic infrastructure or approach that everybody uses. Why this was problematic for us. So the first problem we had was we were struggling to deliver at the speed that our stakeholders wanted us to deliver at. They wanted us to make more changes faster, and we were really unable to deliver them. Whether that goes from even little things like making a content change, all the way up to making a big feature change. We were really struggling to get those changes out into production fast enough. We were dealing with, as always, when you have that kind of setup, you have a lot of branches, you have lots of different versions of stuff, and you end up, through no fault of your own, in an absolute hellish mess of branches. I do a release, and I push it, and I think all's great. And then someone comes along and says, hold on, you spelled out the name of our product completely wrong. Well, but by then, all the other developers have gone off and started making other changes, so we can't build from master anymore. We've got to go back, and we've got to port this into a previous branch, and we've got to port this to master, and we've got to manage all this stuff. And we were spending almost as much time managing this mess as we were actually delivering value. I think the biggest one for me was priorities. So we were also struggling to react to changing priorities. So I think this is one of the things I find most frustrating about software developers, is they often complain, oh, the business guys, they've changed the priorities again. They keep on saying that we need to change what we're doing. That's ridiculous. But I think that's a bad attitude to have, because I think life is about changing priorities. Priorities change. What you need to do does change. And I think what we need to focus on as software developers is how we react effectively and quickly to those changing priorities, rather than thinking about how we can slow down the rate of change. And then the final one we were struggling with, we're the guy on the left there going, I don't understand. My stakeholders are telling me all these random things, and I can't build the things they're asking me to build. So what was the problem here? Well, we felt that our stakeholders didn't have good visibility into what we were doing. They didn't understand what we were doing, and as a result, they were struggling with giving us the information we needed to be effective. And then I think the final thing that we found was that whenever we did a release, whenever we did a build in this way, we had a very poor signal-to-noise ratio. So we would do a build, a week later, it would get pushed to production, and inevitably, as is always the case, bugs aren't found in beta systems. Bugs aren't found in staging systems. They're found in production systems, because people are inherently lazy, and you say to them, we're about to do a release. Could you please go and test the staging system? And what do? They think, I'll do that next week when I'm not in my training course, when I'm not in my meetings, when I've got a bit more time. And they never get there, and they never do it. But when they get to production, they say, oh my God, this is a critical bug. We have to get this fixed right now. And so we were really struggling with this, because we'd find bugs in production, But they were caused by code that was written 2 weeks ago, pushed to master a week ago. How do we know which change caused this? We spend far too much time working out where that bug was. People were losing the context. So this is where we had got to. This is the problems that we were having. And we were casting around for ways to fix this. So I'm going to hand over to Paul, who's going to talk a little bit about continuous delivery, which is the solution that we chose to fix this, and give you a little bit more of an idea of what we think continuous delivery is and what it's about.
Thank you, Pete. Just to attach this. Okay, yeah, so I'm going to start by talking about the differences between continuous integration, continuous delivery, and continuous deployment, and then I'll take it from there. So the way people typically do continuous integration is that they will test their code after it's been merged into the master branch, maybe on a nightly basis. But the key point here is it's being tested after it's been merged in. And any problems that are in the code, any bugs, they're being detected after it's gone into the code base. So some of the time the code's in a deliverable state, so when the tests are passing and all it's good, then great, yeah, you can deliver that code. But other times when there is bugs, it's not in a deliverable state. You have to wait until those bugs are fixed before it can be delivered. So moving to continuous delivery, what we do is we make sure all the testing happens before that code gets into the master branch. That ensures that the code is always in a deliverable state. And then continuous deployment just takes that a step further. Yes, the code is capable of being deployed, and we deploy it on a regular basis, maybe after every change, or maybe just on a daily basis or at some other frequency. So, let's see if this works. So I'm now going to talk about how we've implemented our continuous delivery pipeline using a collection of technologies, so GitHub and Jenkins being kind of the key ones. So so it all starts with the developer. The developer makes a code change on their machine. Once they've made the code change to the site, they raise a pull request on GitHub. This pull request will automatically trigger a build in our Jenkins server. The Jenkins server will kick the build off, and if there's a failure, then it will use the REST API on GitHub to comment back on the pull request and tell the developer what the problem was, and give them a link to the logs as well, so they can figure out what they did wrong. So hopefully from that, the developer can figure out what it was, and they can fix it, and then they can update their pull request and try again. Again, this triggers another build, which will, in this case, this build succeeded. And because it was a successful build, it can now be deployed into a staging instance of the site. And then the build comments back on the pull request to say, here's your staging instance, and gives a link to it. So the important thing here is we've got a staging instance that's particular to that pull request build that can now be tested and checked. So the developer who raised the pull request can go and check that they think it's fine. A code reviewer can go and look at the code, and the person who requested the change can go and check that it's as they expected. Plus, we can do a bunch of automated tests as well, which I'm going to talk about in the slide after this one. If everybody's happy with the change, it's approved. And we hit the green button in the GitHub pull request, and the code's merged into the master branch. Now, we have another Jenkins job that will detect that the master branch has changed, and will then trigger a production build, which will then go and rebuild the production server and have it deployed immediately. Okay. So for our build, the build takes about 10 minutes. So you can imagine, each of these is taking 10 minutes, and then the reviewing, can take longer. But typically, we could turn around a change within an hour using this system. Okay, so what hardware have we got behind this? How are we doing this? So we're quite lucky to have quite a powerful CI server to do this. It's a single server with 48 Xeon cores, 128 gig of RAM, and 6 SSD disks. So it's quite a beefy machine. We then split this machine up into 12 virtual machines. So that means we can run essentially 12 CI jobs at once. Typically, that's quite a lot more capacity than we need. And most of the time, it's quite idle. But the important thing is that when we're under pressure, when there's lots of things going on, lots of changes coming in, we've got the capacity there. And we quite regularly hit full capacity. And we can keep on delivering when that's happening. If we had a smaller, if we had less capacity, then yes, we'd have better utilization. But when it really mattered, we wouldn't be able to do that fast delivery. Okay, so now, so if you're doing continuous delivery, then you've got to test your code much more frequently. Before every change is merged, you have to run tests against it. This means you're running the tests more often. So if your tests involve a human going and clicking around on the website, making sure that things are working, looking to make sure things look okay, that doesn't really fit into this workflow because it's going to take too long. It's too error prone and so on. So you really, you need something that's faster and automated. And then if you want to go to continuous deployment, so you'll find that you're deploying your code much more frequently. And in order to do that, if you're in a situation where somebody has to manually build the production code and copy it across somewhere or edit configuration files and so on, then this isn't really feasible in this pipeline. So this has to be automated. So the key thing here is really everything needs to be automated. The whole pipeline needs to be automated. So when we started to set this up, we sort of took a step back and thought to ourselves, well, what do we need? What sort of tests do we need here? What is it we really care about? And the first thing we thought, well, we don't want broken links on the site, right? That's kind of an obvious thing, right? But we can't manually go and click on every link and make sure it works. We also don't want any broken JavaScript on the site. So we can't go in and look at the JavaScript console for every page and see if there's any problems. So we had a look to see what tools were available to us. And there was a variety of websites that did this for us. So you would log into the website and tell it the site you wanted to check, and it would go and crawl it, and it would tell you if there's any broken links. It would come back maybe 10, 15 minutes later with a result. But this doesn't really fit into a continuous delivery, continuous deployment pipeline because it's difficult to automate this. So what we really wanted was something that was command line driven. So we wanted a command line tool to do this really, and so we could have a Jenkins job that would do it for us. And we couldn't find anything out there. So reluctantly, we had to implement some code to do this ourselves. So we created a tool called Blinker. So it was named after Broken Link Report. And it started by, it's a Ruby gem which will troll the site, and it runs a web browser, a headless web browser, which goes and checks all the pages, and it also executes the JavaScript as well. So now we've introduced that into our build pipeline. And then the next thing we started thinking about was SEO. So we wanted to make sure that search engines could really search our site correctly and well, and we were optimized for this. So we looked at Google Webmaster Toolkit, and that's like a really great resource because Google tells you everything that's making it difficult for Google to troll your site, which is really useful. But again, it's a web interface. It doesn't fit into this build pipeline. So what we did was we replicated the checks that Google's doing, and we built that into the Blinker tool. So we can now spot SEO regressions. So if somebody raises a pull request with a change in, then they will get notified if they've impacted our SEO. So I should probably give you an example of the type of things that Google checks for. It's quite simple things, really. It's things like pages without descriptions in the meta tags, pages with too short descriptions, too long descriptions, images without alt tags, duplicate descriptions, so pages that Google thinks are identical, but they just happen to have the same name, things like that. We can quite easily check for this, and it's now done, automated. Then another thing we wanted to check was, well, when people make a change to the site, it was quite difficult to tell whether they'd only made a change on that particular page. Have they affected one of the other 1,000 pages we have on the site? So a simple CSS change can affect many pages, and it's not feasible to kind of figure out, okay, that CSS might be used here, might be used there, and go and check it. So we thought, well, what we really need to do is we need some sort of visual, really need somebody to compare each of the pages one in the pull request versus what's in production, and we need to know what's changed. So we found a tool called Wraith, which is produced by the BBC, and what we can do with that tool is we can take a screenshot of all the pages in the staging build and all the pages in the production build, and we can run a visual diff over those screenshots, and then the report shows us which pages have changed and where the changes are. So we get like a little blue indication of which bits are different on the page. So then someone can go and check to make sure there's nothing unexpected. And then the last testing we need to do is around functional testing. So we need to make sure that the key workflows on the site work. So we have products behind a registration wall. So you need to sign up for a free registration to be able to download the product. So we need to make sure that a user is logged in before the download occurs. So it's quite a simple workflow, but if it's broken, then it's a critical problem. So we need a way of testing that. So that's not something that we've got at the moment, but it's something that we certainly need quite soon. Okay, so I'll now hand back to Pete, who's going to talk to us about the lessons that we've learned from making this journey.
Thank you, Paul. So, yeah, Paul's talked a little bit about what we did and how we did it. And I think what I found interesting out of this was some of the ways in which we've changed how we work. So I'm going to talk a little bit about some of the lessons we learned. So I think the first lesson we learned is around culture. This changes the way you work as a team. It changes the way that the people in the team work. So some examples of this. Well, this guy saying it. I don't always test my code, but when I do it in production. That's clearly a bad thing. That's clearly not something you want any developer on your team to do. But when you're using a more traditional workflow or process for doing this, quite often they can hide behind the anonymity that all these changes gives them. They can say, or they can even think to themselves, they can kid themselves. I'm not saying this is malicious, I'm just saying they think this. They think, well, that wasn't my change, it was someone else's change on the team. That's not a good place for your developer to be. That's a bad place. They need to take responsibility for what they're doing so that they can improve. Another one that we came across was people who maybe aren't involved in software development, but involved in working with the team. Our visual designers, for example, they got very confused by this new process. They were saying, well, where's my staging build? I want to see what the latest you've got is. And we would say, well, the latest we've got is what's in production. We don't have anything newer than that. What we have otherwise is just the stuff that people are working on. We don't have any other set of changes. And I think the final thing that you definitely have to overcome is just a fear of change. So Paul's a good example of this. Paul started off when we proposed this idea by saying, yes, but what happens if I click the merge button and this goes into production and something's broken? We really need lots of processes to be able to recover from that. We really need to be able to have good rollback mechanisms. And in practice, what we found, I think we've rolled back once in the entire year, and we probably do 2, 3, 4, 5 pushes a day. So we've done, probably a couple of thousand pushes in the last year, and we've rolled back 1 or 2 of them. So we're at a 0.1% rollback. And that's because what we've always found is because we're making much smaller changes with this, it's always easier to move forward rather than backwards. It's nearly always easier to fix the bug than to say, I need to go backwards, I need to undo the change, I need to retest it and rebuild it. And that's a result of making much, much smaller changes to things. So the next thing I want to talk about is infrastructure. And what I mean by infrastructure is not just your hardware, but also your software, and the amount of time and the amount of effort you put into your technical debt or your technical projects that you do at work. So these are things where there's no clear business driver for this. You're not delivering new functionality, you're not delivering changes to your site. What you're doing is improving the processes and the systems you use to build the site. Paul gave some really great examples of where, by investing in automated testing and focusing on what we really needed there, we were able to improve our throughput. Yeah, okay, it took us a bit of time to do that, but at the same time, it meant that in the end, we were able to review changes faster and get them up onto the system faster. Paul again talked about the amount of hardware we need. you need a lot of hardware to do something like this. This is not. I do sometimes wonder if continuous delivery was invented by people at Intel or AMD in order to sell more processors and more chips, because it involves taking vast amounts more hardware than you need in a more traditional workflow, because you're building and fully testing every single change that you make to the system. You need to avoid anything that produces downtime, anything that involves creating false positives or false negatives in your testing outcomes. You need to become incredibly reliant on your infrastructure and your systems and your processes. But if you can do that, it's brilliant, because suddenly it goes from the situation where I remember being in for a long time of, oh my God, we've got to do a release today. This is going to be a really stressful day. I need a beer lined up at the end of it so I can recover. We better get everybody on standby. We better not do releases when anyone is on vacation, because if we do a release and the critical person is out who needs to fix this problem, we're going to be broken. And you go from a situation like that to a situation where you completely trust your infrastructure, you completely trust your release process, because you're doing it multiple times every day. And that, as an engineer, is a much more comfortable place to be, because you just know that this is going to work. It's not stressful. It's just part of what you do every day. So I've talked a little bit about some of this, I think, on the previous slide. But the other thing you have to do is you have to be prepared to be brave. You have to be prepared to, stick your neck out like this guy is doing here. You have to be able to trust your skills. You have to be able to trust your infrastructure. I think the other thing we wanted to highlight here was that if you have a manual process, there's often things that aren't actually properly written down in your manual process. There's things that I wrote the process, I always do the release, and my environment is set up like in a particular way. Or I assume that I've got a particular tool installed. I have to take some time off. Paul starts doing the releases. And suddenly he can't release because he doesn't know everything that I knew. When if you have a system like this, the release is fully automated, and so you don't have to worry about it. So I'm not going to stand here and pretend that everything is perfect. We still have lots of open challenges. And I think I'm going to hand back over to Paul at this point to go through some of those open challenges. Am I, or am I supposed to keep going? Oh, sorry, I'm supposed to keep going. I apologize. So what are our open challenges? Well, we still have a pretty difficult setup for people to get started with. We don't have it as easy to get started as we wanted. Whether that's to do with having a continuous delivery pipeline or not, I'm not sure. I think that's probably just something that we have to deal with anyway, and that's just probably a reality of life. We've got problems, other problems definitely outside of continuous delivery, like issues with our content providers being able to contribute easily to the system, but that's just a common problem. To go into some of the ones in more detail, so I think the first one is that Paul talked about the VMs that we use. The VMs we started with them because, I guess like a lot of people, someone on the team knew how to set up VMs, so it was a good way to start. We didn't have to learn any new technology. We could just get going quickly. But the problems we've hit with the VMs is that if something goes wrong, someone has to SSH into the machine and fix the VMs manually. We don't have a nice automated way to get those fixes in, so I can test it on my laptop and push it up and get that change into the CI environment. And I think probably the main thing that concerns me is that we don't have any way of versioning or controlling the versioning of our VM environment. The VM environment determines whether the build succeeds or fails, but it's a little bit random. It's just what's running at the moment. So we would like to move away from that. So I think the next thing that we've really hit is just like the guy who's about to light a fire in his fireplace, and he lights the fire, and he causes a chimney fire, and he burns the whole house down. So why? Well, because someone made an unexpected change. The birds nested in the chimney. The guy didn't expect this, and as a result, he had a catastrophic problem. And that's definitely the case here with continuous delivery. When you have a more traditional environment where you do a push every week, you probably do a manual check of the system before you push it. Oh, there's a problem. Right, let's go and fix it. It was caused by some outside factor. Okay, we have to deal with that. Here, you never ever manually check. Well, you never completely manually check the entirety of your system when you push. You always you're relying on your infrastructure to do this for you. And if someone introduces an unexpected change, that's going to creep into your production system and break everything. So you spend a lot of time worrying about how do I protect my system against unexpected changes in data, unexpected changes in APIs, unexpected changes in any external factor. And so I think what I want to say here, really, well, the point I want to make here, is that this has a habit of creeping or getting its way into all of the things you do. You think, we'll just do continuous delivery for this, and then you suddenly realize, oh, we should do it for this as well, and this as well, and this as well. And it kind of has a way of spreading out. And it's definitely easier if the entire organization that you're working in is bought into this idea, rather than you trying to go it alone. So the final thing that I would say is that, so like Paul said, every time we make a change, we rebuild effectively the environment, retest the entire environment. And the real struggle there is legacy systems like this one up there. You know, you've got this system, it's a database, or perhaps it's a, perhaps it's a database, perhaps it's just a system that hasn't been moved over to this way of thinking, this kind of DevOps way of thinking yet. And that means that when you do your build, you either have to mock out that system, or you have to connect to a single instance of it, and you have all your builds conflicting over what they're doing to it, and you can very quickly get into a mess. So again, this has a habit of sort of getting its way into all areas of your organization. So those were some of the challenges that we faced. I'm going to hand back over to Paul, and he's going to talk about some of the challenges I think we're facing in the future and some of the ways we're thinking about fixing them.
Thank you, Pete. Okay, so one of the problems we have at the moment is that so our site is kind of the content is kind of split into two groups, if you like. So we've got a lot of automated content that we can generate. So for example, for every video that we index, we have a video page, which has got some extra information on it for like sharing the video and so on, and it fits in with the site. That can be all generated at build time. But then on the other hand, we have a lot of pages that are very content heavy. So for example, each of our products has a page where a content creator has generated that content. And really the system, we try to make it work for both situations. So we use AsciiDoc for the content pages. So we thought should be easy for a content creator to edit AsciiDoc files, which it is, but due to the way we do templating, we do a bit of magic in the AsciiDoc file so that we kind of mark out which sections need to go in which part of the template. And we use headings as the way of specifying which sections need to go where. So there's some magic going on here. And when we have things like this, it becomes difficult for the content creator to start editing the content in this workflow. Plus, they need to use, for example, they need to use GitHub to raise a pull request and so on, which it's actually pretty user-friendly, and they can get to learn it, but it's still quite difficult for content providers to use the workflow. So we felt that really the type of system that they want is a CMS, right? They need something that's got a more familiar interface to them. So we wanted something where a content creator could go and see the page that they want to edit, click edit some bits of text, submit it for approval. That approval then is done by maybe a copy editor, not an engineer. So today we have engineers that are approving pull requests, right? Probably not the best people to be approving text changes, but that workflow is tailored for them. And so we felt that Drupal was probably a good case for this because Drupal gives us this as a CMS, but it's also highly programmable. Engineers love it because they can really extend it. And one of the things that Drupal has is it has a REST API for creating pages. So you can push pages into Drupal via a REST API. So we can keep the content-heavy pages as first-class citizens, if you like, in Drupal, so regular Drupal pages, and then the statically built pages can be pushed in via the REST API via our site build. So similar workflow to what we have now. Okay, so I'm going to now talk about how our environments change now with a move to, when we move to using Drupal. So, one of the other things I wanted to say was Pete's already talked about how we're having a lot of problems with engineers setting our environments up and things. That's quite a lot of work. And it's also a bit of work setting up the staging environments as well, especially with using VMs. So now that we've moved to using Drupal, we're making it even more complicated. So you're not just building static content, now you need to have a Drupal server running as well. And that Drupal server has configuration, it has a database and so on. So it's getting much more cumbersome. So we needed to, so we've moved to using Docker for this. So the idea is that we will have, on a developer's machine, they will have the Drupal instance running. The configuration for Drupal will be part of the, is in the source control. So a developer can make changes to the Drupal configuration, they can make changes to the site build, whatever, all in the same source repository. So they can run it all on their machine, they get a production-like environment running locally. When they're happy, they can raise a pull request with the configuration changes in and the site build changes in, content changes, whichever, and that gets then built in staging. And then once that's been checked and tested and we're happy with it, it can be merged into production and the production server can be rebuilt using that same configuration and build changes. And we're using Drupal, we're still using Drupal to serve up static content, or we will be when we have this fully set up. So that means we can still take advantage of Akamai to give us the fantastic performance that we've got today. So we've still got Akamai serving up this static content. One of the kind of outstanding challenges we've got is that we really need to synchronize the data between each of these environments. So the production server has some associated data. So this is the state of the pages in Drupal, the data for the things that we've indexed, the things that's been searched over, and so on. This data really needs to be synchronized in the staging environment and in the development environment as well. Otherwise, we haven't really got a production-like environment. If we're working on stale data, then we're not testing how this is really going to work in production. So if the data is stale, we don't really know until it goes into production whether the changes we've made work with the current data. So we need to make sure we're synchronizing this data back. The other issue we have as well is we need to make sure that any schema changes that are needed need to be done in a controlled manner. If we go and make the schema changes straight into the production, then there's going to be a mismatch with development and staging. So all schema changes have to go through as upgrades through the continuous deployment pipeline. So you would test out the schema change in the development environment first. If it works, it goes into source control and is raised as part of a pull request, and then it's tested in the staging environment, and then finally the production environment. Okay, so we've talked about the problems that we're having with using VMs, and essentially our approach for managing this group of VMs was to clone them, hence the cryptic photograph. This is Dolly the sheep, for the cloned sheep, for those of you who don't know. So what we were essentially doing is managing a single VM and then cloning that. When we made a change to it, we would clone that VM out to the other servers, but it was very cumbersome. The configuration wasn't inside source control. It was all done manually. We'd manually configure this single VM and then clone it out. It wasn't great. So we also had the problem of this capacity issue that I talked about earlier. Most of the time, the capacity on our servers was low, but when we really, really needed it, it was high, and we were sometimes our jobs were being queued up. So we had that real mismatch, despite us having a pretty serious piece of kit to run this on. So we're now in the process of moving to a Docker-based approach. So I'm sure you've all heard lots and lots about Docker this week and prior to this week. So I won't go into too much detail, but essentially it's a containerization technology that utilizes SE Linux for isolation. So the idea is that we're moving away from VMs. We're putting all our services and things inside Docker containers, and we're then using Kubernetes as a way of orchestrating those containers. We're quite lucky we have a OpenStack instance inside Red Hat, so it's quite a large cluster. So OpenStack gives us an infrastructure as a service environment. So we now have the ability to scale up and scale down the capacity that we need, rather than having all this hardware laying idle. Okay. So I'm going to show you what our runtime architecture might look like when we move to this. So as I've said before, this is still something that's in process, and this is not necessarily how it will be eventually, but this is kind of what we're thinking at the moment. So Kubernetes has the notion of an application which is composed of a series of pods. So the grey box is the application. Inside there we have these pods here, which are units, and those units can talk to each other. And Kubernetes manages that connection between, the communication between those pods. So it manages the connecting up the sockets and so on for you. At this stage, we're thinking we should split the application up into these pods. So we have, my pointer's not working. We have the Drupal pod, which will contain the Drupal server and its database. So the Drupal server is one Docker image, and the database is another. So that hopefully will allow us to restart the Drupal server while keeping the database running. We've also split up our search engine to Cisco. We think maybe this should be split up into 3 pods, because I'll explain how it works first. But the Cisco server here is kind of like the REST front end to the service. It's really, the actual computation is actually going on in Elasticsearch. That's where the heavy lifting occurs. And we need to be able to scale out Elasticsearch and scale it down. This is really where the processing happens. So we feel this should be in a separate pod to help scalability. And then Cisco also has a database which it stores its data in that's been indexed. That's basically read when it boots up, and then Elasticsearch will then do the actual runtime queries. Okay. So this is what it looks like at runtime. These are the services that we'll have running. But then there's also the build time as well. So we talked about this, us generating this content. We're generating all this static content via a build. So we use a tool called Allstruct, which is a site baking tool, basically. It's a bit like Jekyll. And that's needed to generate the pages that are pushed into the Drupal server. So that's only needed at build time. So it's only needed when the site is being built. Once the content is being pushed into the Drupal server, that can shut down, and then it's done. So it might seem a bit strange that we've decided to move this into Docker as well, but actually it gives us a couple of really great features. So the main one is reproducibility. Now that everything is inside, everything is with Docker, and the configuration of that is in source code, it means that we can completely reproduce the particular environment that's running from a particular version in source control. It makes it very easy to reproduce problems. And the other thing as well is that just setting up Allstruct on your machine, there's several dependencies that you need, and we pull in content from lots of different providers and things, so we use a variety of libraries and things. And there's often, when an engineer gets started with this, they often have problems, and it takes a while for it to get working. With Docker, once you've got Docker installed, that's it. You just run a command, it's up. Much, much easier. Okay, so I'll now hand over to Pete, who will talk about the DevOps side of things.
Yeah, so you're probably wondering, we put DevOps in the title, and we haven't really talked about DevOps at all. And I think that's because we feel that DevOps is really much more about the cultural side of it. It's about the idea that people own the entire life cycle. So we have a cross-functional team going all the way from the usability, the UX and the visual design through, and the business people, all the way through down to the people who are actually deploying the code onto the servers. And we have a single team, and that single team takes responsibility for all the functionality. And that, for me, is what matters about DevOps. What matters about DevOps is this idea that the ownership is of the functionality and of the software, and it's not about what you do. So for us, yeah, DevOps is interesting. It's a cultural change. It's much more an organizational change. But something like continuous delivery is what enables us to get to that point, and the important point about DevOps, where everybody is taking responsibility and ownership of what they do. So to summarize, where are we with this? Well, we love it. We think it's been a massive productivity win. We can deliver a lot faster than we could before. In fact, I think we've kind of forgotten what it was like not to have this. So when I talk to other guys within Red Hat, and they talk about what they're doing and all the pain they have, I think, wow, I'm glad I don't have to go back there. This is a much better system. In fact, I think we've kind of forgotten, like I said, forgotten what it used to be like. So, I was talking with Paul, and he said, oh yeah, I can barely even remember what we did before. This is just so much better. So yeah, we are big fans of this. What would I emphasize, sort of, leaving you guys at the end of this? Well, I think we've become a lot more agile, and I don't mean agile in, sort of process terms or Scrum or anything like that. I just mean we can deliver what the business needs us to deliver quickly. We can change direction quickly. And we can deliver what's needed when it's needed. We've become more productive. I think we've learned to trust our infrastructure and learned to trust the processes and the systems we use. And we've learned that it's really worth taking a lot of time. I think we, as a rule of thumb, say we should take around 20% of the team's time building the systems and building the automation and building the processes we're going to use. And that pays off in the long run. We've increased the transparency. So we've gone from the point where people are saying, sorry, why do you want to spend 20% of your time improving your systems, improving your processes, to saying, please, could you spend some more time improving your processes and systems so you can get more productive and you can continue this rate of change? Challenges, to summarize, there's definitely a problem with scale. This kind of has as I said, has a habit of ballooning out and becoming something that becomes very infectious and takes over the entire thing you're doing. Everybody has legacy systems. You always need to deal with legacy systems. And you need to build a system that's really reliable. You end up relying on this system, and when it breaks, you have a problem. So if we rely on Jenkins, if our Jenkins infrastructure goes down, we have a massive problem because we've set very high expectations with our stakeholders now. Our stakeholders expect us to be able to turn around changes quickly. And so as a result, when Jenkins goes down for an hour and our deployment time goes up to 2 hours, we start getting in trouble. I mean, luckily, we have nice guys, so they say, oh, yes, we understand Jenkins is down, it's OK. But, you set higher expectations, and you also become incredibly reliable on your infrastructure. You become completely reliant on it. And I think, finally, I'll go back to the final point, which is, I think one of the things that has really worked for me in this is it's given us a way of solving those problems that we as engineers want to solve, those problems around our technical debt, solving the systems, getting the systems right, but doing it in a way that has support of the people who decide the business value and drive, other stakeholders. So I think it's produced a situation in which the whole team, and by that I mean everyone, is more comfortable. So that's what we wanted to say. I hope this has been interesting for you. It's different. It's not necessarily about technology, and it's not about JBoss products. It's kind of about the journey we've been on. I'm very excited about this. I think this has a real possibility to improve the way we work. And if you've got any questions, we would love to talk to you about what we're doing, any suggestions about what we could do better. So thank you very much.